This is a very low budget, fully DIY Bluetooth portable speaker. It has a 3D printed case and all the components inside are low cost. In a past tutorial we have built another Bluetooth speaker using this board with the TDA7492 amplifier. Now I want to build another Bluetooth speaker but build my own circuit and also reduce its price. The TDA amplifier board from the other video was around $8, which is not much. But I would like to lower the price even more, using recycled old laptop batteries, an expensive 3D printed case, and build my own amplifier circuit. To receive music using Bluetooth connection, I want to hack this small and very cheap module. In this way, my project will be fully homemade and also for a reasonable price. So let's get started. What's up my friends, welcome back. I can say that the receiver is the main part of a Bluetooth speaker. But we do need a Bluetooth connection, and for that I've chosen this small module. This costs around $2. You could establish a Bluetooth connection between your smartphone and this device. Then play music and you will have the music signal at this output. My idea is to connect wires for both right and left sound outputs and connect the signal to an amplifier. Now we should talk about the amplifier. I want to use the TDA2030 sound amplifier because it's quite cheap. Before we go further, I want to say that this amplifier is not the best. You could only use another one if you want and keep the rest of the project the same. The TDA2030 only amplifies one channel, so I should use two of them, one for the right and another one for the left audio channels. This is the basic schematic that I've mounted for this amplifier. Here we have the potentiometer that increases or decreases the input amplitude, and by that lowering or increasing the volume. So if we want a stereo output, we should have two circuits like this one. But I don't want to have separate potentiometers to control the volume separately for each channel. That would be very awkward. So for that I will use this kind of dual potentiometer so I could change the amplitude of the signal of both amplifiers at the same time. The good thing about this potentiometer is that it also have a switch integrated that could turn on and off the speaker, so we won't need a separated switch. Finally, I will use some lithium-ion batteries that I salvaged from an old laptop battery that I don't use anymore. I will use this module to safely charge the batteries and the boost converter module to increase the voltage for our amplifier since the batteries only have 3.7 volts. I've designed my own case for this project and 3D printed using PLA material and my Annette E10 printer. I will use these forum speakers from an old audio platform that I don't use anymore. The main idea of this kind of projects is to reuse any part that you can. So let's begin. Since there will be two channels, this is the final schematic that I will mount. You could download it from a link below. Make sure you have it in front of you while soldering. Also, I recommend you to first try everything on the breadboard and make sure that everything works okay. The full part list, prices and 3D objects are in the description as well. Okay, let's start. This small and very cheap module could charge a 3.7 volts lithium battery and also protect it from overcharge or discharge. It also have a USB connector, so you could use it with any 5V USB charger or directly from your PC. I take the 3.7V lithium batteries and connect them in parallel to have more capacity. I will charge 3 batteries in parallel, so you might want to use a balanced charger. But I won't do that for this small project in order to keep the price low. Okay, so you have to connect the charging module to the battery and the output from the charger to the amplifier circuit and to the switch that we talked about earlier. In this way, the batteries could charge, but the entire system will only turn on with the switch. Next, we should increase the voltage for the amplifier to have more power. For that, I will use a boost converter module. This will boost the 3.7 volts to exactly 12 volts. For that, using the small potentiometer that the module has, you can change the output while measuring it with the multimeter. Turn the potentiometer till you get 12 volts. If we check the datasheet of the TDA 2030, we can see that the maximum input voltage could get up to 22 volts and a maximum output power of 18 watts. I will leave the voltage at 12 volts to be sure that I will have no problems. That should be more than enough for this project. Now we should mount the amplifier circuit. Using a drilled PCB, I solder all the components following the schematic before. I connect all the components except the volume potentiometer. I start by adding the two amplifiers. Next, I will solder the diodes at the output, followed by the 100K resistor between the output and the inverted input of the amplifier. I add all the remaining resistor and capacitors and the PCB is ready. It's not the best looking PCB, but it does the job. As you can see, I haven't soldered the volume potentiometer on the PCB. The reason for that is that I want to be able to screw it on the exterior part of the case and then connect it to the PCB circuit. So for that, I solder long wires between the potentiometer pins and the PCB. I also solder the speakers to ground and the output capacitor of the amplifier. Now I carefully open the Bluetooth module. I solder 3 wires from the output jack. One is common ground. The other 2 are left and right channels. Make sure and double check in order to know which one is which. Solder the wires from the module to the volume potentiometer and from there to the amplifier input. And remember to solder the forum speakers to the output of the amplifier board. By the way, you also have the full schematic with all the components of this project in the description below. The receiver has this small push button that enables you to change the mode when pairing the Bluetooth device. Without removing the small push button, I solder 2 long wires to each side of it. To these wires I will connect my own bigger push button. In this way I could also screw this button to the exterior of the 3D printed case. The Bluetooth module is also supplied with a 3.7 volts battery. I first remove that and directly connect the 3.7 volts pack that I've added before. Be careful and don't connect the boost converter output to the Bluetooth module. That will burn it out. This configuration might work, but didn't for me. I've tested the final circuit. At low volume works okay. But when I increased the volume at each sound peak, the Bluetooth receiver was restarting itself. I guess that the boost converter draws too much current at high volume. I've tried to solve that by adding a big capacitor to the 3.7 volts output, but that didn't work. The Bluetooth module has a very fine voltage detector that turns it off when it's low. So I had to connect back the small LiPo battery that the receiver had, separated by the other battery pack. And to charge it, I will use the charging circuit that the module already has. For that, I've just soldered 2 wires from the 5V connector of the battery charging module to the USB input of the Bluetooth receiver. For that, I first connect a USB to it and test which is the 5V input. Once I found it, I solder wires between the 5V output of the charging module and the input of the receiver. Now, with just one USB connector, I could charge both of the 3.7V battery pack and the small battery. As you can see, both charging LEDs are now turned on. Since the Bluetooth module has a charging circuit, it will stop charging when the small battery is full. But that won't stop the big battery pack charging process. Maybe this problem is just in case of my receiver. You could try both options. You have both schematics below. Now, as an extra part, I desoldered the LEDs indicators of the charging module and soldered two larger LEDs, one red and the other one blue, same colors as the module has. Using large wires, I could glue these two LEDs on the exterior of the case in order to know when the battery is fully charged. Now the circuit is ready. We should probably add a heatsink on the back of the amplifiers to keep them cool. I test it before mounting it inside of the case. I make sure that the batteries are charged. Turn on the circuit using the potentiometer switch and establish a Bluetooth connection. Open your smartphone Bluetooth settings and search for devices. Once found, I connect to it. Now open your music player and press play. The circuit works and sounds quite well for a DIY project, and I'm sure that it will sound better inside of the case. Speaker cases are designed to improve the sound acoustics. So, we have the batteries that are connected directly to the charging module and also to the boost converter. The 12 volts output from the boost converter goes directly to the main switch and from there to the amplifier PCB. Here we connect the audio signals from the Bluetooth module and the speakers at the output. The LED indicators, push button, charging module and volume potentiometer will be placed on the exterior of the 3D printed case. So let's mount the speaker. Before that, I measured the voltage and current to obtain the power. At maximum volume and using two 4-ohm speakers, I've measured a mean of 2.6 amperes of current at 3.79 volts. That gives us an output power of around 10 watts. Each TDA 2030 amplifiers could deliver up to 18 watts. We could increase the power of our portable speaker by increasing the input voltage up to its maximum voltage of 24 volts, but with these small speakers that is not necessary. If you use a 2S or 3S batteries, you should also consider a different charging system with a balanced charging device for 2S, 3S or even 4S batteries. But that will increase a lot the project price. Anyway, the maximum voltage for this amplifier is 22 volts with one polarity and the 44 volts peak-to-peak dual polarity voltage. So make sure you won't supply more than that, unless you want this to happen to it. This safety charging module could only charge 1S batteries of below 5 volts. If you want to put more batteries in series to obtain 7.4, 11.1 volts, you should also use a balanced 2S or 3S charging and protection module. The rest of the circuit should be the same. Now that I know that the circuit works, I prepare the case. I've designed and 3D printed the case using my dear Annette E10 3D printer. The 3D design already has holes for the potentiometer and switch, the battery charging indicator LEDs, the pairing push button and the USB plug for the charging module. I screen place the potentiometer and glue the LEDs on the 3D printed part. Next, I screen place the push button. I position the charging module to have the USB connector exactly in front of the hole. I glue it in place using hot glue. I take the 55mm diameter speakers and fit them on the 3D printed parts. I make sure that all the components won't move and that are well glued in place. I close the case and this project is done. Finally, for a final test, I power it up turning the potentiometer switch. Next, I long press the push button till I hear the Bluetooth mode sound.
Bluetooth mode.
I connect to the Bluetooth module and play my favorite music. Now with the case, the sound quality changed a lot. The 3D case already has holes in it in order to let the speaker's membrane oscillate freely. I could also add some extra LEDs inside to make it look cooler, but I want to have more battery life for the speakers. To charge it, just plug any USB to the USB charging module. The red LEDs will turn on and the blue one once fully charged. The Bluetooth module will turn itself off when the battery is low. I've used the speaker for around 6 hours. After some tests, I found that the fully charging time is between 3 and 4 hours, and that at full volume it lasts around 6 hours and the maximum power is 10 watts. You could always add more batteries in parallel to have more lifetime. The project could always use any other amplifier chip than the TDA2030. Or if you don't like soldering your own circuits, there are already soldered modules for 99 cents, or DIY kits ready to be soldered. You will find a bunch of examples in the description below. The total price for this project without the batteries and speakers was around $6. With the Bluetooth module for $1.75, the two TDA amplifiers for less than 50 cents, the potentiometer for $1, charging module also for 75 cents, almost none for the 3D printed case, and a few dollars for the extra components like capacitors, LEDs and resistors. The batteries in my case were free. I've left a link for some lithium-ion batteries if you want to buy them in the description. Usually you could get a pack of 10 batteries for around $15, so that would add $3 more to this project. You could also buy a 55mm speakers for around $1.5, so let's add $3 more to this project. So we could approximate the total price of this project to about $12 or $13 using only 3 lithium-ion batteries. But the best thing about this project is that we made it. That worth more than any other portable speaker. I'm pretty satisfied with the final results. It looks so nice. The color of the case is amazing. We have all the controls on the side and we could charge it with any USB charger. Since the 3D filament that I've used is translucent, we could even see the pairing LEDs of the Bluetooth module through the walls. The sound quality is not the best, but you could always improve that just by using any other amplifier. The rest of the project should be the same. Check my webpage for more details and all the information that you need. You could find there more photos of the full part list of this project. If you want to support me, check my Patreon page as well. I would really appreciate that. I hope that you enjoyed this tutorial. If so, don't forget to click the like button like crazy and share the video with your friends. If you have any question about this project or any other, just leave it in the comment section below or my Q&A page. Also, don't forget to subscribe and watch all of my other great tutorials. If you consider helping my projects, check my new Patreon page and help my workshop grow and have a lot of more other cool tutorials. Thanks again and see you later, guys.